So week two, we're going to be doing data acquisition and wrangling. And there are all kinds of data sources. And I'll probably want to start with the kinds of data formats that we have. You have structured data, unstructured data, semi-structured data. I probably mentioned some of this last week. And then there are also sources where ways and places where you can get all of this data. And that's some of the things uh, that are available here as you see. So I mentioned um, I mentioned structured data. So like your Excel sheet, right? Everything is properly structured, columns, the columns, you have the columns, you have your rows and all of that. So something like that is structured data. Then you have semi-structured data, JSON, you see JSON files. I guess let me show you for those of you that might not be JSON files. Let me just say formats, right? For those that are not very familiar with JSON files, let me see an example of JSON file. Let me see if we can look at this here. No, this is all telling stories. What is a JSON file? Um, I'm trying to find, so you would see things like this, right? They are kind of semi-structured because they have some kind of structure. So it's like they look like dictionaries. Remember, I discussed with us last week what dictionaries were, right? Where you have a name and then like a dictionary is you have a word and then the explanation. So you always have name, and this is Jack, age 30. Even though it's not neatly organized like Excel sheets, it's kind of organized. You can see it. This is another example of a JSON file, right? Everything is really organized, even though it looks disorganized, but it's actually organized. And then you see the parentheses, the open and close parentheses. Somehow, all of that, you know, helps organize and put things in perspective. So that's an example of your semi-structured data. Same thing with XML. And then you have the totally unstructured data, things like text, like I mentioned when we are when on Facebook or LinkedIn, all of that, when you're chatting with people, all of that information is very good. You go to an organization's website, right? And you're leaving a recommendation. A lot of people come there, leave recommendations. Sometimes it can be a little chaotic, but sometimes some of that unstructured data can actually be ingested as JSON files, and some other times not. And some other times, all you can actually get as semi-structured will be the metadata. And what is metadata, right? Metadata is essentially that part of data that is not necessarily the actual data that the user is bringing in, but it's things like timestamp, the identifying piece of the data. That's what you call metadata because you're going to be hearing terms like that. And then the sources, right? There are all kinds of sources. One of them is APIs, which are application programming interfaces. These are like interfaces that help maybe websites talk to other websites. Just think of it like interpreters that help two entities pass data between one another. And we're actually going to show you an example of how to use APIs, right, to collect data from from a source online. So the other thing you see is internal databases. All of us are kind of aware of what internal databases are. And then you have IoT devices, which is essentially sensors and all of that. Um, then
Excuse me, sir. Are you
mm,
sharing screen?
yes, you can't see my
I'm
screen.
not. No, I can't see anything.
Oh,
Yeah.
Your screen is showing. Maybe she should log out and log in again.
Oh yeah, okay. See whether you can log out and in again. But if you still have a problem, just speak up.
Okay.
Because if I have to um
The
go,
screen is showing.
okay, all right. So um acquiring data using pandas, right? One of the things I did, excuse me, one of the things I did with the class, if you still remember, let me go show you something in the classroom, right? So this is syllabus, resources, and for those of you that are doing the Python class, right, or that are not even doing it but want to see what those of us that were out through the week were doing with the Python class, this is the videos that we watched during that we recorded while I was teaching them Python, the refresher course. So you can always come here and see the videos. And like I mentioned, right, you can get you can get the files. I showed you where you could get the files, which is in the streaming section. This is the files in the streaming section, but I was trying to show you something else, but I wanted to use this opportunity to go back there. So week zero, these are, like I mentioned last week, these are placeholder videos. You don't really have to watch this or do anything with this, but they are reference materials that you can always go to. And one of those ways that one of the tools are what we call packages, right, in Python. And these are all Python packages that you can use to do all kinds of things. Pandas, for example, is for data manipulation and analysis, which is what the subject of this week is. So if there's anything you can do for yourself is to understand, watch some video. This is one video here that you can watch if you really want to understand how to use pandas to do data manipulation. You have NumPy, mostly for numerical, like if you're doing um, numerical analysis, this is for manipulation, but this is for analysis. And then this matplotlib is the package in Python, and we're going to encounter most of this as we progress, right? This is for maps, and then this is also for maps, but more of high-level visualization. This is for visualization, high-level visualization, and this is for machine learning, and this is more for statistical modeling. And the way I want to explain it is just like you have your Windows and all of that. Sometimes you want to install packages. So think of Windows like your Python, and then your packages like Microsoft Word and all of that. And sorry, I'm dumping it down because I know not all of you, a good number of you already have that higher level knowledge, but I'm saying it because of those that might not have a lot of background in data science. So that's what this packages are. So I'm going to safely go back to where we are. And I mentioned that because I said I'm acquiring data using pandas, right? So normally you install pandas, and import pandas after you've installed, a lot of times in your like Jupyter notebook, right? Or your Jupyter lab, it would have already been installed. But it's normally, if it's not installed, you would install it with something like .pip, pandas, blah, 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 and that's how it gets installed. And again, if you have a problem installing pandas, just go go to installing pandas. Because there might be some times where it will just throw up some kind of error. This is the documentation, how to install pandas, and you will see all of that, like, right? This doesn't really, no, this is, um, if you go click, so often you would read through something like this, right? And look at the kind of thing I'm mentioning here, pip install pandas. Now, pip doesn't work anymore. I think there's been an upgrade. So usually you would use like an exclamation mark before pip, then install pandas, and that's how pandas gets installed. So I'm going back here, pip install pandas. So if this was throwing up an error, I would just come here and say pip install pandas, right? And it would install it. But if I try installing it now, look at what it will say. You know, it will, in just 1 minute. So you see, it says requirements already satisfied. In other words, pandas is already installed, so that I don't need to do it. That's why. So I'm going to remove this and then run it again. So you see, it doesn't throw up that error that is the requirements has already been installed. So the first thing is you say import pandas as PD. Imports essentially means like going into your computer and clicking the MS Word, Microsoft Word to open up. Microsoft Word is a package in Windows. Windows is like your Python. Microsoft Word is like your Pandas right now, right? And once you say import Pandas, you are essentially opening up Pandas. But then you want to hyphenate Pandas because you don't want to keep writing Pandas all of the time, right? And that's why you're like, okay, if you see a legal document, they would say um, um, Chief Ben Carlson in brackets, hereafter referred to as Chief, right? So I don't have to do that whole thing. That's exactly what's happening here. Import pandas as PD. So PD is the same thing as pandas. And then I have a URL. Of course, we all know what a URL is, right? Like a website address. And then one of the things you're going to figure out about pandas is that it helps you create data frames, right? So um, a lot of times that's why you come see they will do something like df is equals to, now this is your pandas dot read underscore CSV. Essentially, this command helps you read the content of this URL, right? And then the next line is, remember I said a lot of times when you have a variable, which is what df is, df dot head. Dot head is essentially a method. What is a method? A method is literally almost like a function, which is something that gets a variable to behave in a certain way. In this particular place, dot head is essentially saying, I want you to print out the first 5 items, right? Because this probably has, let's just I haven't checked how many rows it has, right? But hypothetically, you can have a document that has 1 million rows, right? So to be able to start your exploratory data analysis, you just go click dot head, and that's how you begin to get a feel of what the document is. So that's the first 5. So if I decide to say dot tail, I'm essentially telling it, show me the last 5 rows. So notice this is 5, 3, 14, 0. Well, when I run tail, it gives me something else, right? 6, which is giving me the last rows. And you can see, so I can literally tell that this has 149 rows, right? So this, and what you have here is
150 rows.
150 rows.
Prof, the class is
So,
not being recorded.
oh my God, why not? I thought it was.
No,
Oh
it's
no,
being
it's being
recorded.
recorded. Sorry
Yes,
about
it's
that.
being recorded.
Yeah. So it's being recorded. So um so what we have, right? Then I can literally go back to head. So this is important. This is what you call the index. It starts indexing from 0. So I said 149 and Prof corrected me. It's 150. And the reason why it is because you start indexing from 0. So it starts from 0 to 149, which is 150 rows. So Another way you can, you know, you can do this is essentially, okay, let me do something. So remember, this is what we have, right? If I was to just go open it, sorry about that. If I was to just go open it and let's see what it contains, right? This is what you have. So this is that data actually. So all I was doing is I'm like read it into an a CSV file, which is what it does here. It essentially reads that into a CSV file. And that's why it's read into a CSV file. But why did it now develop all these, why does it look so nice, right? All of that is what Pandas helps it. You use Pandas to do. It lays it out very nicely and gives it a heading, an index on the side and all of that. So that's what we have here. So
Sorry,
ne-
sir. Is that like a JSON file or something?
which of
The link, what you showed us when you went to that link.
no, it's not a JSON file. I wouldn't call this a JSON file because what would I call this? This is essentially like a
CSV,
CSV
CSV
file.
file.
Yeah.
Yeah, it's a CSV
But sir, I
file.
have a question to ask.
Yeah. Go ahead.
Yes, is the file online? That is why you use the URL.
Correct. Yeah.
Okay.
It's stored online. If you look at it here, you would actually see it's raw data from someone's GitHub account, it seems, or something like that. Okay. So, and then, yeah,
Sorry to ask.
yeah.
The GitHub, my account was rejected several times. I tried to sign up. I don't know what is the factor.
Which of your accounts?
When I'm trying, I'm trying to create the account for GitHub.
Oh, okay. Well, I mean, we'll talk about that. We'll do
Okay.
GitHub sometime today. We'll look at it, and even if we are not able to resolve it, we can take that offline. So
Okay.
yeah,
Okay.
just I don't want to forget, and then I don't do anything about it, and you think I ignored you. Just remind me, especially when we're about to close, if I don't get back to it. Thank you.
Okay. Yeah, thank you, sir.
So we can load CSV from a URL too, right? And this is what we do, almost the same thing. PD, read this, blah, blah, blah. But then look at how this is structured. Let me copy this file, right? And show us what's going on. You see, it just downloaded the CSV. So that's a little different from what we did before. There's an actual Excel sheet that opens up there. And then I do the dot head too. This is essentially just a variable, right? Dot head, and then it gives me the head, and I can check the tail. I can do all kinds of things. I can check, I can query, do an analysis of all kinds of things here. And then this is your JSON. So for example, you see, like I was mentioning, JSONs are almost like dictionaries, right? Often almost like dictionaries. So you have name, Alice, age 25, city, New York. Somebody come up with an idea of something else I can include. So we'll create a string, right? Height. We can say height.
Gender.
Yeah. Okay. Gender. Sorry. Gender, right? We close. And I'm doing all of this to show you that even though it's looking like it's kind of complicated, it's not. So Alice is female. I can say Alice female, right? So this is what we had before. Let's try to run this, right? So all of a sudden our gender has come in there as female. So this is an example of a JSON file, but often it's when people go enter information online that it can automatically be curated as a JSON file, right? And then you can extract that JSON file, and then you can begin to analyze that JSON file. So what's going on here, right? first of all, again, remember the import, you're importing the pandas file. And then the next thing is you're also importing JSON. JSON is literally like a package of its own. And then you're doing it from and then from IO, which is another package, you want to import string IO. So a lot of times, maybe this IO package is so large, you don't want to bring all of it. You just want to take a certain portion of it. That's what's happening here. And then you do your reading. How did we read? But look at what's going on here. And I've taken out time to try to explain what's going on here, right? You can see it. So when I say from IO imports string IO, essentially this is what it means. From IO imports means you are importing the string IO class from the IO model. So this is actually like a model, right? In Python standard library, right? String IO is a class that allows you to treat a string like a file. So, we created these whole strings, right? But what string input output actually does is helps us convert these strings into a file. In these cases, we already had the files, but here we don't have the files. All we have is the data. The point is, how do we do that conversion from strings into data? So the point is, a lot of times you're going to see these packages doing things. And what are these packages? What are these modules? They're essentially pre-built functions, right? In the back. Again, I talk about in programming, you do a lot of abstraction. A lot of those things have already been done for you. All you do is just call it up. Instead of creating an entire Windows program, the Windows program exists. I just call up the Windows program and then I do what I want to do. That's what we have there. So that's what the IO string. So what we are doing here is importing the IO class from the IO string IO class from the IO model in the Python standard library. The IO is a class that allows you to treat a string like a file. So it provides a file-like object that reads and writes a string buffer right in memory. So because you've converted it to a file now, right, then you can apply methods like read, write, or seek to that file, which you ordinarily cannot perform on a string, right? So when you want to use file operations like read, write, seek, etc. on a string without actually reading or writing a real file on disk. So essentially you have to do that conversion for that to happen. So this is another example. When I say from IO import string IO, right? So I've given this data. This is data I have. And some of you, I want to think, since all of us here have some familiarity with Python, you already know what's going on here, right? What's going on here is all of these, first of all, is a string. You have your name, comma, age, /n means go to a new line, right? Alice, comma, 30 / go to a new line. So that's why when you run this, all you're seeing is each time it says go to a new line, it creates a new line, creates a new line. This is essentially just indices, right? So if I wanted something else, another line, all I would just do is say N Peter, right? Peter has to be older than all these other people. Let's put Peter there, right? And then we've created, and this automatically generated the index, right? But the point I was trying to emphasize is where string IO, all of a sudden, what it does, it literally converts it. Look at the file, the variable, it can be called anything, right? But it's just helping you to say, hey, it's creating this object that has a file-like behavior. And then when you put it in here, all of a sudden it begins to behave like a file. So when do you want to use a string IO? When you are working with functions that expect a file object, but you only have a string. So those are the kind of times where you want to call up string IO. They're great for testing file processing code without creating actual files. So the other example I'm going to show is how to use APIs. Remember, we mentioned the whole thing about APIs. Um, um, we mentioned the whole thing about using APIs, and APIs are application programming interfaces, like I mentioned. And one way to think about them, they are like errand boys, right? You have Uncle A and Uncle B, right? The guy that runs errands between both of them, maybe both of them live in different towns, and maybe one of them is incapacitated and he can't even move to go see the other person. One person runs between both of them to relay messages or to bring information back and forth to each other. And that's essentially what an API is, and I'm going to give us a use case. Um, so a now we use Python requests. Usually APIs uses like the Python request library. So, and it handles responses in JSON. Usually you can see what's going on here, right? These are like essentially how and it requests authentication API keys for some services. So I don't know if for those of you that have used API sometimes, right, you have to generate a key. You go to Uncle A's place, right? Uncle A gives you like a package, you know, but and then for that package to be opened, right, there has to be a password, right? And then once you get to the other person, you pass the information to. So think of it like this, right? You can Uncle A can generate a password, right? Send it by text to Uncle B. And then API will come to Uncle A, pick up the package, but API can't open that package. When API gets to Uncle B will enter the code that Uncle A sent to Uncle B, and then the package will open, right? So kind of how that works, and that's what you call your API keys. And usually they are a long string of numbers that you can use to get access to the information, excuse me, that you're looking for. So we're trying to, so we're saying we are importing requests. Again, like I mentioned, this is one of the libraries. And then your variable response, which can be anything, right, is equals to request.get. Request.get is what you use to try to get information. And I explained that a little bit because so when I give you when I upload the Jupyter notebooks, you would actually be able to understand everything step by step. And then your data response.json. So look at the two important things: response.get and response.json, right? And then data.keys. And I explain, let me see, I think this is where I explain what every of those things does. So import request, this imports the request library. So let me put this here so that you know that this is, so I'll run it so that it's unique. So this is a specific type of library which is used to make HTTP request in Python. So if I want to get something from a HTTP, like a website, right, I have to use the request library, right? And then in that request library, it has a couple of methods that I can use to make it behave in different ways. So what I'm using in this particular place is get. This sends a HTTP GET request, right, to the GitHub API. And this is my GitHub API, which could be essentially where I'm getting my data from. Now, this particular command here, right, sends a HTTP GET request to the this particular URL. The server responds, and the result is stored in a response object, which is this. That's where you store all of that in the object. But then this converts the JSON, from the server into a Python dictionary, which is a JSON file. Remember, we're talking about your JSON files being typical dictionaries. And then what the data.keys does is it returns the top level keys. And I'm going to explain what this is. So in a JSON file, remember, let's go back here. Let me show you an example. So, so this is an example of a JSON file, right? So normally a JSON file has what you call key values. I mean, it's very intuitive if you think of it, right? Keys and then a value, just like a dictionary, you have word and meanings. So in a JSON file, what you have is keys and values. So name, for example, is a key, and A is the value of name. Age is a key. 25 is the value of that key. City is another key, and New York is, because the value can change, but the key is the static thing, right? And that's why you call it the value to that key. So in this place, right, what it does mention to us is, it says something here. One of the things the data.keys does, right? And remember, this is a method, right? All it does is that it returns all the top level keys. And I'm going to show you what it means when it says all the top level keys of the data dictionary. The main fields return to the GitHub API roots endpoint. So what are top level keys? Just a minute. Or maybe let me just do this. 1, 2, 3. So what are top level keys? Top level keys, right, are simply keys that are directly inside the dictionary, not the nested ones inside another dictionary list. So this is an example, right? In this case, what are the top level keys? The top level keys, right, would be user, right, and location. So what it's saying is the keys that are further out, not the ones within the nest. So this is another key, but these are within, they are nested inside these ones. So that's what it calls, right? So let's run. So essentially, this code, what this code does is that it essentially fetches public data from the GitHub API root endpoints, right, and displays the available fields. So this is what it's done. Essentially, just picks all of that information from this place and displays it. And that's one way of fetching data from is a site. This is another example, and see what's happening here. This is essentially like a website, you know, it's a typical URL, I haven't checked to see what's here actually now. So this is an example. This thing is listed somewhere on a website, right? I can just come in here, right? So I said import request, and I say URL is equals to, I enter the website I want to get information from. Again, remember your request.get and then put your URL. Then data is equals to response.json. I want it in JSON. Then the data frame, when I say df on, again, don't care about this. This is just a variable. You can call a variable whatever you want to call it. The things you want to pay attention to are the things on your right, right? So PD, remember your PD, pandas dot data frame. I'm essentially saying um, use pandas, right? But use that method, right? Which is data frame, which is what makes it behave in a certain way. I need you to create a data frame of the data that I'm getting, which is a JSON file, but I want to convert it into a data frame. And this is what, remember I told you this is what a data frame looks like, right? You know, this is not part of the data 0, 1, 2, 3. These are just indexing. The data starts from this particular point and all of that. But each time you want to get data together and put it in a nice little table, right? That's what Pandas helps you do. And then it helps you, gives you all the methods and functions to manipulate that data, right? And then that's what you have. So look at this, and then all of a sudden look at what we have now. And the simple difference is that you've used, an API call to fetch that data, and then you've converted that data using a data frame, right? And then you've run the head. I can run the tail, with tail, I can actually tell, okay, like how many, yeah. So it's just 10 rows of data, so that's how it ends. So it's not a lot of data. So the third way you can get data, is by web scrap.
This is not easy.
You're not supposed to like know everything. Again, it's just like language, right? Language is not easy, but if I ask you right now the different ways you can extract data from a website, at least you can talk about, different ways of, extracting that data. But then, like I mentioned, anything you're looking for right now is available online. All you need to do is just Google it and you get the information, you know. Nsa, you were trying to ask a
Okay,
question. I
okay,
see.
sir.
Yeah.
Yes, sir, that's correct.
Mhm.
Can you hear me, sir?
Yes, sir.
Fantastic. Thank you so much so far. I must say, getting a bit of tough time really understanding the JSON, getting data from JSON files. But I think I'm following closely. The question I want to ask is, how do we know a particular website uses JSON file? Okay, I want to go to this website and pull some data. How do I know the data is JSON file so I can come follow all these processes? How do I
Yes.
know?
Uh no, so you don't have to know that a site uses JSON file. So JSON is just a file format, right? So every file you can decide to pull data. Uh, but what I will say is, first of all, let's do the web scraping, right? So that we'll come back to it. Because, like in this particular examples I gave you, right, you actually had actual JSON files. But what if I want to just go to a regular website that doesn't have, things organized that way, which is where web scraping now comes in.
Okay, all right,
Excuse
sir.
Right.
Thank you so
Yeah.
much.
Hello,
Mm. Yes,
I have
sir.
an input.
Yeah.
Yes, I feel to his question. I feel that the this thing is what is being done here is guiding us towards what we may be facing tomorrow.
Yeah.
Yes, so I feel that many of us may be walking through different sources
Hmm.
and meeting any source, having known what there are different kind of file structure,
Hmm.
structured and unstructured, and then can be kept in these various sources. So the knowledge helps us maybe to take to the
Different
data,
kinds of problems.
yeah,
You
do
make
what we're
sense.
expected to do.
Yeah.
Thank you.
So to his point, right? You know, the rest of this class, you might not actually need all of this, right? Because you might go somewhere and just get an Excel sheet, and all you do is the first thing that I said, where you just go say blah 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 is you just load a CSV file, and that's all. But all of these cases are where, for example, you want to go to a website to go fetch that data, But most times you probably will just get existing data. And if you, let me go to, where's the class? So if you come in here, right, finding and assessing data, one of the things you're going to notice, and remember there was someone that was telling me to put some of this in URLs. This is it. So let me go here, for example. 10 great places to find free data for your next project, right? If you go to Kaggle, for example, this is my Kaggle account, right? There are all kinds of data that you can get. And notice here, all of these are CSV files, right? So you don't have to go through that whole scraping. It depends on the kind of data that you're looking for. But because we are going through a class, right? I'm trying to just like stock market data, Netflix stock price history, right? Maybe over time. And then it will come here and tell you what's included. You have your date, stock open, high, low, close, and why use this data set? It will tell you everything about the data set, tell you about this makes data ideal for all of these kind of places. For example, Arima Prophet. I think I mentioned all of that in our syllabus. LSTM, which is your long short-term memory. This is mostly around deep learning. You can use the time series data here to do some deep learning work, right? That's partially why I want us to do the project we are going to be doing, so that you get familiar with deep learning, neural networks, and all of that, right? And then if you want to do technical trend analysis, this will be good data for it. You want to do some predictive modeling with machine learning, you can use this data to do it. And then for those of you, that are into data analytics, you can actually use it for Tableau or Power BI type work, right? Who can use it? The data is designed for blah, blah, blah. Students building machine learning projects, AI researchers working on time series models, financial analysts. So aspiring data scientists practicing exploratory data analysis and modeling, and then this is the data here. This is the data. If I click it right now, it downloads. Or I can click here, and this is where the data set is, zip, and then you can unzip it. Oh, I have to log in. Seems like I'm not even logged in. So, but to Joseph's point, that's exactly, one of many ways, right, that we can do it. But I'm just showing us a full complement of different ways, because if you're going to be a serious data scientist, you might be confronted with the need of getting data from different places, and the video and the files that I give you here will be very helpful. And notice that I take my time in explaining some of these things so that they won't be foreign to you. The first time, think of it for, those of you that drive, the first time you try to drive, it was scary, right? And then the first time you try to get on a highway, it felt like a truck was going to run you over. But then after you started driving, right, sometimes you don't even think about your driving, you just drive. That's how every other kind of learning happens. So for some people, they are just getting exposed to this today and it's looking like a lot. But in your various disciplines, you can tell where you are coming from and where you are now and how scary that is for anybody outside here. Yeah, Christian, go ahead.
Okay, so just still on this point,
Yes,
I
sir.
also think it's a question, it's a comment. I also think that based on what was asked, it also depends on what the person who prepared the data set had in mind and
Yeah.
how he is distributing it.
Yeah.
So, for instance, if in a particular website somebody provided a particular data set, he would have told us whether it's a JSON dataset or whichever format that he has used to display it, so that we now know in whichever of these three means that you are providing that one will be able to get the data. I don't know whether I'm correct or I'm wrong.
No, you are correct. And the areas where you're correct, right, is if it is data that is prepared, just like the ones we went to go look at right now, those all of that data is carefully curated and kept there. So if you go to a lot of international agencies, right? So maybe you're trying to understand world hunger or or you're trying to understand wars and you're trying to understand a lot of those things where these international agencies like the World Health Organization, the United Nations, and all of that, they prepare all of this data and keep them online. But there are certain times where all you're just doing is you're actually going online to scrap data. So a lot of airlines, right? o- On their website, they are not in the business of giving anybody data, but you can actually go to their websites to get information um, about flights, flight delays, all kinds of things about their flights. That is available.
Sorry,
Yeah.
and what are the ethical implications of that, like the web scraping, which you're about to enter?
So that's part of what we are going to also talk about, right? Because the way the world is kind of designed, right? We are especially in places like the US and in the UK, right? Data is purposely put out there because the governments believe that data is beneficial to society, and people would need data to make decision, whether data, all kinds of data, right? So in most cases, it's okay, even for the websites. That's why you go. Some websites actually provide APIs, right? Which is your application programming interfaces, so that people can fetch the data they need, right? But then, which is one of the things I talked about here right now. So we can use requests, which is your library, Python library to get HTML. We can also get HTML, right? So to the person that was asking the question, sometimes it's not just JSON, sometimes, for example, if it's a website, right, then in cases where you do JSON, might be things like if you have a website or like Amazon, right? People have left a lot of comments, so maybe that will be you're trying to do sentiment analysis on the comments, right? That might be a JSON file, for example. But if I'm going to go to a website to go scrape data, then it might be HTML because that's the basis on which websites are. So, but to your question about ethical, you know, the ethics of scraping data from websites, the first rule is that you should now you see robots.txt. So this is a special file usually located on websites. So you see something like this. Let's say there is a website .com/robots.txt. This tells web scrollers like Google bots. These are all kind of automated bots, right? Or your scraping scripts, the script you're using to try to scrape, what they are allowed to do and what they are not allowed to do. So normally that's on the site. So for example, if you have something like agent hyphen user hyphen agent, and then it puts a hash, right? And then it puts, just think of this script, disallow slash private slash. So there are certain parts of that website where the scraper, right, or the web crawler cannot access because those areas are private. So if you're creating a website, right, you need to be able to make certain aspects private and you're supposed to make some others public. If you go make something that's supposed to be private public, then a crawler can just come, and just crawl and go in there and get all of the information that you have. You know, the person even collecting the information might not know. So it's incumbent on the owner of the house to lock the door, right? Except when it becomes ethical is unethical is when you're trying to gate crash into the door, right? So in parts of the US, right? A couple of places, I've lived. What happens is like if If I'm tired with some furniture or the refrigerator, I just bring it in front of the house and I drop it, right? And maybe in the next 30 minutes or 1 hour, somebody pulls up with a truck and just carries those things and goes. That person hasn't stolen it, right? Because it's a tradition. We know that if you drop that thing there, it's okay for people to take it. But if I have those things inside my house and somebody comes to break the door to get it, then that person is a thief. So kind of. So in this particular place, this code, right? All bots or the crawlers should avoid these particular private paths. That's what this instruction, for example, that will be contained in your robot box says. So respecting the instructions, right, in this text really means checking it before scraping and not scraping areas the website disallows. And then there's also the rate, because there's a thin line between you trying to hack a website, to your point, and just coming there to collect important data that you have. So that's the second consideration beyond finding out what's in the robot.txt file. You also want to look at the rate limits. Websites have servers that can get overwhelmed, right? If you send too many requests too quickly, which is almost like what hackers do. They bombard the website. So, but there is an allowable limit, right? Rate limiting means spacing out your request, e.g., one request per second, to avoid overloading the site or getting blocked. So, respecting rate limits is actually means not hammering the site with rapid fire requests. So in your code, you might want to add something like time.sleep between the requests that you're sending. So one of the tools that you can use for web scraping, and there are a couple of them, but this is one very popular one, right? Is called Beautiful Soup. So it says Beautiful Soup is a popular Python library used for web scraping. That is extracting data from HTML or XML documents. It allows you to parse, which is read and navigate web structure, and extract specific content like text, links, images, text, table, and all of that. So that's what Beautiful Soup does. So this is like a breakdown of what it does. When you download a website, usually with request, remember, let me put that in because this is a specific library, right? The content comes as raw HTML. Beautiful what after you extract it, just like we had the extraction going on in the JSON, right? Here in this case, it comes as raw HTML. Beautiful soup lets you read and clean the messy HTML data, navigate the page structure, searches for elements by tags. You can actually look for specific things, and then you can extract and manipulate the desired content. So this is an example of a beautiful using Beautiful Soup. So we're trying to scrap this website, right? Let me copy this website so you can see what's there. So this is a typical website, right? So we are trying to scrape that website, and then you come here. Where are we? This is it. So I come in here and I import request, which is the Python library that helps you pull information. And then you're getting this from this particular library. You are importing Beautiful Soup, which is the one that does all of this stuff that we are talking about. Then the URL is this. Remember your get request.get is what pulls the information from the website, just like in the JSON case, right? But then after you have done that, then Beautiful Soup takes over, where it now begins to organize that data in a way you want it. So soup, which is, again, this is your variable, you can call it whatever you want, is equals to Beautiful Soup the parameters, what parameters are here. And I'm going to talk about these parameters later because I might want you to tell me the parameters of different things, right? And I want to show you because it's very important. I want to show you how to identify parameters of all kinds of things. So soup is equals to beautiful. This is the response.text. That is the response, what I gathered from here, right? But I want to convert it to a text document. That's why I said .text, comma, and then I use HTML the parser to pass. And what does it mean to pass? Right? I mentioned it somewhere here, right? To navigate, to read and to navigate, right? In other words, to chop it up, extract what I want from it. And then that's where you now go into when you've navigated and all the walls that are created there, you've been able to get through them, like your CSS, all you've been able to get through them. Then you can extract. The first thing, you can do all kinds of things, right? One of the things you can do is you can say, okay, let me get the title from all of that data I have dumped. So I say soup.text, title.text, right? Then I will try to print my page title is title, right? So if I run it, look at how it gives me page title is equals to this. So there are all kinds of commands that I can use to pull all kinds of things. Well, the second thing that was pulled here is let's pull all the links. For links in soup.findAll, you're trying to find all of the links there, right? And then you print your link.gethref, which is your way of pulling links, right? Traditional way of pulling. So all it has done here is the only two things you got here, and you can get all kinds of things. You got your page title and then the URLs, all the URLs that are on the site. These are all the URLs. So, for example, these are different features that you can use, to get all kinds of things that you're looking for. But again, I'm just bringing this to our attention. As you begin to practice, you begin to notice all kinds of ways to do all kinds of things. So here I listed how to install, if it's not installed already. When to use Beautiful Soup. We want to scrape websites that don't provide APIs. So there are certain websites that don't provide you APIs and you want to do the scraping. You're working with structured but messy HTML pages. You need fine control over element selection and text extraction. So those are all times where you can use Beautiful Soup. And then this is another example. So this is not an actual website, but if you're familiar with HTML, you can understand what's going on here, right? This is just hello world. This is just hello world. But what has happened is you put a H tag on it, and then you put it within a body. And then, so the HTML is what makes it kind of a website. So we're just trying to, the only content here is your hello world, right? So let's use Beautiful Soup, right? And we want to pass the HTML, right? And that's why we're able to get, and then h1.text. That's how, look at what I'm trying to pass is this. That's why I brought it here. And then HTML.pass. And essentially I print it out, right? It gives me hello world. So this is another example too. If you go through the whole thing, same thing. In this particular place, I'm looking for the job title, I'm looking for the company, I'm looking for the location, and I use every single thing that I have here. And that's how I was able to gather all of this data from this. This is the place where the information came from, right? And then take your time and look at this file, and then that's how you're able to create all of this. So it's the same thing. I just put multiple examples that can help you go through things. I think we are going to stop here for now, take a little break. Maybe let's come back by 10:20, if that's okay. Come back by 10:20. We'll do a bit of uh I'll do- let me just see. Yeah, Christian, go ahead.
Okay, sir. So thank you so much.
Yes,
But
sir.
going back to the question I asked in the beginning about the ethical considerations, you
Yeah,
mentioned something about the robot.txt file
yeah.
that you're supposed to follow. Now, does Beautiful Soup have any way for you to liaise with the robot.txt file to know which files the owner allows you to scrape and not to scrape? That's the first one.
Mhm.
Then the second question is, doing this web scraping, are you also able to scrape front end things? Let's say the HTML files in the front end. Are you also able, like when people talk about web cloning, site cloning, when you do scraping of a website, are you also going to be able to use that same data to clone a website? Is it possible? Thank
Um, hmm. So first of all, the part of Beautiful Soup, right? Remember what most of the getting information from the website itself, right, is essentially just using your get request.get, right? What Beautiful Soup, as you can see here, let's go back. Look at the kind of things Beautiful Soup does, right? It's essentially reads and cleans the messy data. So it's not heavy on the um, extracting the data. It just helps you, understand, because if you have a website, right, one of the things you do is you have your HTML, you have your CSS, and it's, if let's say there is an ant trying to walk through all of that, you see all kinds of walls stopping you from doing that. But Beautiful Soup collapses those walls, right? And then helps you pick out different elements from that soup of data that you have gathered. So if I may, and I'm certainly not an expert with Beautiful Soup, but I think where the focus is, right, on what you can get and what you can't get is the interaction with the get request, request.get. But that will be something you need to like go into much, because I think most of the processes are automated. I don't think it's something where you go manually and start checking all of that. It's the web scraper that has to do that. But sometimes people create applications or bots, right? And they don't want to follow the rule. They want to literally jailbreak into systems. And that's why cybersecurity becomes very important. So, to the extent of cloning a website, I think the best that I know that Beautiful Soup can give is it can give you the content of the interface, which, like, it's very easy to get the content of any interface. You can actually see the code. I can't even remember. Let me see. How do you do it? It's usually somewhere on the side. It's pretty easy for you to. You don't even need to use any tool to do that, and you can see the HTML of any code. The only thing is, you know, because the interface is just the interface. It's just, think of the interface like a house, and the painting, all the painting you put outside your house, they are still open to the elements. But your hope is that somebody doesn't come to your house and start scraping the wall. But it's not like if they want to do, they can't do it. But what is important is to protect your back end. All right. I hope I answered, did justice to that question. But I'm going to do let me just do a quick run through of this, and then we stop, take a break, and then come back for the next part, because I need to show us a couple of other things, right? So, um, when it comes to data wrangling, that's where the heart of most of what we're going to be talking about are. But then there is a lot of information around data wrangling. There are a couple of videos that I would have us watch privately on our own, that do a very good job. And that's why I'm like, you need to understand pandas a little bit if you're really going to be good with data wrangling. So there are all kinds of things, all kinds of methods, and these are not the only methods. In fact, yesterday I put together like about 4 different um, Jupyter notebooks that I will be sharing with us or walking us through, but I don't know if we would have the time to do that. And all of that around data wrangling. You have things like sorted. You have things like there are a whole bunch of methods and how they work. But I'm going to just walk us through some of these very simple ones. So for example, I have these are, just look at this, right? I have name. So this is like a dictionary, right? But it's a dictionary that is embedded with a list. So from here to here is a list, right? Right? But the whole of this, so think of this as your key, and this is your value. So it's a dictionary. So this is your key, just like I was describing before. This is your value. What we are used to is having name and one name, but in this particular place, we are given the opportunity to actually list different things, right? So, but one of the things we started with was to use pandas to convert this to a data frame, and that's why it's looking pretty and nice here. And these are the index, which is not part of that data. So all we just did was raw data. Let's make this raw data into pandas data frame, and then we put the raw data inside here. And then when you run the raw data, you get this. But notice what's happening here, right? Emily doesn't have a salary. That's number one. And then number two, a lot of things are in K, 50K, 60K. But you know what? I want to convert these things into actual numbers, which is 50,000, 60,000. And I want to do something about this none, and maybe I want to do something about this space. That's elementary data wrangling, right? So first of all, I start by cleaning the salary column, right? So, and I say raw data, and then I put in square bracket, right? Salary. What I'm essentially doing, remember, raw data is the name of the file. But when I put this in a square box and I pick up salary, all I'm doing is I'm calling on this column. So if I was trying to focus on this column, I will put name here. But in this particular case, I'm putting salary. Right. So the next thing I do is also I use my PD, which is my pandas. You know, let me show you a breakdown, because I deliberately put all of this because some people will be like, what's all this and what's going on here, right? Which is why, when I showed you the pandas video, I thought it's important for you to watch the pandas video because it will give you a breakdown of one of the things, for example, you're going to keep encountering every time is string dots replace. What does string dots replace do, right? It has at least 2 parameters. I have to look up the parameters, how many parameters it does. Let me just do something. I'll say pandas string dot replace, right? So this is an example. So this is the syntax for, right. So this is important, right? Just pay attention, because one of the things I talked about parameters I'm showing it to you now because I think I'll try to put 2 or 3 questions in the multiple choice thing, right? I'll give you specific methods and I'll ask you to tell me what the parameters are. Now, if I came here, right? If you look here, right, we only have 2 parameters here. We only have 2 parameters here, the value of 2 parameters. But if I come here, right, and all you have to do to find the parameters is just go type in the method or whatever like this, and then say syntax, right? str dot replace plus syntax, something like that, and then it will give you the syntax. This is the syntax. So for almost every method you have, in programming, it has a specific syntax, right? So this is an example of the syntax for string dot replace. Now, what you have here is a parenthesis. The first thing you have here is the old string, and I'm going to explain what that is. And then you have the new string. So here, the old string, right, is the string to be replaced. That's what you call the old string. That's one of the parameters. This is one of the parameters. The second parameter is the new string. The new string you want to replace the old string with, which is string or callable to replace instead of all this grammar is just saying what you want to replace this guy with. And I'm going to show you. Let me see. Let me see if there are any questions. I'm transcribing. Duh, duh, duh. Before you write the code to display. Sorry about that. I'm just trying to, it seems like I missed some. Oluchi said, how does that work, please? Oluchi, what are you referring to?
I'm actually referring to the person who is saying I'm transcribing because he has written it twice. That he's transcribing this call with.
Oh,
so I'm not asking him, but he didn't answer.
Oh, okay. He's probably that we have all kinds of things. Maybe he's listening in, he's using an application that is listening in, right, and just converting it to text for him.
Okay.
Right. So the third thing is the number of replacement to make in a single string, right? Default is -1, which means all. Case takes Boolean value to decide case sensitivity, make false for case insensitivity, all kinds of things, Boolean value. But whatever all of this is, these are all what the parameters are, right? So in this case, we have how many parameters? 1, 2, 3, 4, 5 parameters. So this is an example. You have something like this going on, right? Blah, blah, blah. Students, full name. These are the full name of the students. These are their father's name. And as this is literally like a dictionary with a list embedded into it. That's what you have here, a dictionary with a list embedded into it. And then you create a data frame using student full name and father's full name, right? And then your original, let me see, I'm trying to see what the output is. Okay, this is the original data frame. And then you want to replace the gaps with, so you see what they are trying to do? There is an underscore here. You want to replace that underscore with a hyphen. Notice all these underscores. These underscores, they want to now replace it with a hyphen, right? So you say df dot replace, and then if you go back here, you see old string, new string. So usually you go put the first thing you want to replace, and then I don't know why they put a plus here. I thought it was supposed to be, you're trying to replace this with a minus. Let me see what they did finally. Oh, so they did plus. This is an error in the comment. This is supposed to be a plus. Because see, that's what they did, plus, 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 plus. But let me just show you an example, the same thing that's going on here. But the only reason I brought us here is, I never planned to bring us here, but it's just to show you that every single thing you can find out what the parameters are, right? So in our case, we have two parameters or three parameters that we are using, the old string and the new string. So if we come back here, right, notice what's going on here. For this method, right, we're saying string dot replace. This is our old string, which is the original string that we have here. But we are trying to replace it with a new string, right? Which is, instead of K, I want 000 to come in there so that it will be 50,000 properly written. And then this error is equals to coerce. What does error equals to coerce do, right? Look at it. PD dot 2 underscore numeric, right? And then you put it in this bracket. This converts the resulting string into numbers. That's what this first one does, right? Converts the strings into numbers, integer or float. That's what PD dot. And this is, it's not something you create. This is something that already exists. And how do you get familiar with this? By just, watching videos, experience, to know all of the methods that pandas uses, and this is one of those methods, and these are the parameters within. So let me just do this. Let's come here because I want us to really get this right. Syntax. This is the documentation. So you see the syntax. So you have argument, errors, and downcast, none, right? So your argument could be a list, could be a tuple, it could be a 1D array, or it could be a series. That's what your argument is going to be. So let's go back here, right? Let me see, because there's one other thing that I didn't mention. Okay, let's go back. Let's go back. Sorry. I'm trying to find, there's a place it explains the dot, 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 because the dot, dot, dot essentially says whatever is there. I thought I explained that somewhere here, but I probably would. But the first dot, 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 right, is just telling you all of the things that you need to gather, which is all of this information, the raw data under salary. Remember, raw and salary just means all of this. So that's all of what's represented. Where is it here? And then the second part, errors is equals to coerce. Let's go back, right? In the parameters, it says errors. You can use either ignore, raise, or coerce, but the default is raise. So if you're using raise, then invalid passing would raise an exception, right? If the passing is invalid. But look at what we are interested in. If coerce, then invalid passing will be set as NaN, which is NaN is that there will be nothing there at all. So let me go back here. So it says it's errors, right? If a value can be converted, it is replaced with NaN, or a missing value, because of errors is equals to this, right? So for example, this is an example. I can convert the 60K into 6,000. But if I have something like ABC, which is invalid, it will give me an NaN. And NaN, just means that there is nothing there, right? So I'm taking the time to kind of try to explain all of this, and that's why I broke it down here so that when you see it, you would understand. So that's what all of this does. But in simple terms, what were we trying to achieve? All we're trying to achieve is to replace K with 1000, which is what happened here. We go from this 50K, 60K, 70K. So let's assume, let's kind of make it like 50 million, 50 million, and 70 million. If I want to convert it to million instead of thousand, all I need to do is 1, 2, 3, right? And then I run it. Why is that giving me an error? It's not supposed to. Oh, sorry, I haven't run this. I have to run this first, M, and then I can, oh, this is supposed to be M2, right? You see where we're going with that. So that's essentially what it is. I can replace anything here, or I can leave it. Let me go back to K. That might be better. And then I would explain one more thing, and then we move on K. What did I create an error of? Wait, K. Okay, 1, 2, 3.
You didn't run the K.
I didn't run the K,
They
right?
run the previous one.
Okay, cool. Yeah, but notice the other thing,
Hello, hello,
right?
Doc.
Yes, sir.
Yeah, I'm having a very serious network glitch. I don't know. Can I get a copy of this your handout? Can I get it?
Yeah, it's always going to be there. Like I showed us where it was going to be. So if you go into classroom, right? If you go into classroom, you should be able to see it here. Go to streams, you see Python notebooks, the location, you click it. So this is where I'm going to put it, Saturday lectures. Is it okay? All right. So, but notice, so this command, right? Errors is equals to coerce. Remember what we said it was, right? What did it do for this? It says anywhere, uh, um, the passing is invalid. In other words, any place where what you have, right, doesn't jive with what you're trying to, your KKK, right? Just change it to NAN. And notice what it does. Here, I came here and it puts NAN, and then here it puts NAN because it couldn't find the key. That's essentially what this error coercing is. And how am I able to tell that? I can tell it from the parameters, right? And these are the two main parameters, the argument, which could be a list, tuple, or whatever, and the errors, right? What kind of error?
Sorry,
Yes, sir.
what is looking out for? Is it for the K or for a number? Is it for a
It's
numeric value or for a K? What is it looking out for?
it's
The
looking,
the
so it's
errors
looking
dot
out,
coerce.
is looking out for what? Which of them? Are you talking of this?
Yes,
Sorry.
under that salary, that particular statement there,
Yeah.
where it now talks about the error equal to coerce, which which you have been explaining.
Mhm.
Okay, so for explanation, I understand. Is it not looking out for whether what you now finally have is a number? So if it's not a number, you should put NAN. But if it is a number, a numeric value, then it should put in the numeric value. But if it's
Well,
not a
in a
numeric value,
sense, you're correct. But so essentially, what it says, right? It's not just K. If you say it says if you can't convert whatever you meet here, just turn it to NAN. That's all it just really says. Because look at what it says, right? If a value can be converted, it is replaced with NAN or missing value because of errors equals to coerce.
okay, thank you.
Yes, sir. Thanks for pointing that out too. Okay, so that's a typical example. So what I would encourage us, right, is there's a video I wanted to run us through here, right, of a specific use case, and I probably will show it a little bit before we end so that you would want to actually watch it. There are two videos I strongly recommend. By the time you go through those two videos, they would help you to begin to know how to do all of this. And hopefully I will prepare to give you even more methods for doing all kinds of things. But because we might be running short of time, I'm thinking maybe I should create those videos and just make them available so that you can watch it at your own time. Because this amount of time might not be enough, because this particular topic is actually a very critical topic that can help us. But as a summary, what we have done for this here is I've been able to show you how to go ahead and replace, str dot replace. So you put what you want to replace here, and then the other thing. There are all kinds of ways. So I can also decide I want to replace the whole thing. There are all kinds of things that you can do, but the important thing is you put in what you want to replace and then what you want to replace it with. So this is another example. I'm trying to combine two data sets, right? So let's say if you look clearly at this, you see data set 1 is equals to, we get our pd.data frame, which is what creates the beautiful data frame. And then this is a dictionary, which is an ID is equals to this list 1, 2. Score is equals to this, right? So this is, two dictionaries that are embedded, right? This is a dictionary, and then this is a dictionary. So, and then the second data is also like the first data, but what we are looking is ID and then the grade, right? So if I want to combine these two data pieces, how do I do it? I can use combined. And again, remember, this is a variable. You can use any word. So don't pay attention to whatever. I can call it A, I can call it but. We're using combined to be descriptive for you to remember what's going on. So is equals to PD. So this is the method. PD is where what we are using, the pandas dot method, right? So let's go. And sorry, I'm taking this route, but I think it's important because it can help you always remember what you're doing and why you're doing it. And you can see examples, right? In case you run into, I can't remember what I'm doing. So this is an example, right? So I go import pandas as PD. Data 1 is equals to, I open and I create this dictionary. Data 2 is this. I create this dictionary. Data 1 is equals to PD dot data frame, the dictionary 1, dictionary 2, and then my new PD is df dot merge, and then open and close parentheses. So you have the first data frame, and then you want to merge it with the second data frame. So this parameter, what does it do, right? How, where do I want to put my df? So let's see the syntax, right? Data frame dot merge. What are all the parameters? The first parameter is right. So the other thing to always remember, sometimes some parameters are required and others are optional. So you can see here, they said the right is actually required. So in this case, where is it? Merge. So the right. So this is the required one, right? Which is your right. DF. So all these other ones are optional. But then there is one of them that they used here is how is equals to right. Let's go here. How is equals to right. So the default, right? How is right. The default is inner. So it specifies how you want to merge that particular data frame into the other one. So that's what this how is. So if I want to put it in a particular place, I want to put it to the left of the other one, or to the right, or to the inner. So let's go back to our file, right? So what we are looking at, pd.merge, and then on, let me see, one of the parameters here is on. Okay, look at on. And on is optional, right? Specifies in what level to do the merging. Am I doing it as a string or a list? Let me go back here. And he said I'm trying to use my ID to merge. So we are merging around the ID. So, and that's what we have here, right? What's let me see. Let me try something else. Score and see what happens here. Why did I get that error? Let's see. Oh, key error. Oh, wait, I don't understand the key. Why do we have a key error? Let me see. Key error, duplicates, ID. Yeah, this I have to.
I think it's because there's no grade or
There's no
score
what?
on both. There's no grade or score on the two different data
Oh,
sets.
you are correct. You are correct. You are correct.
The only thing that is in between them is I.
Yeah, let's do let's do let's experiment with this. Data tree. So why the truth value of is ambiguous? Definitely use empty dots, any or all. Okay. Yeah, let me get rid of this. Because I think this allows us to merge. I think this allows us to merge two things at a time. Per 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 this. In just 1 minute. Data frame, right? Yeah.
So I think the issue
Sorry, go
is
ahead.
the ID there is more like I
The
think the
common,
ID is we use that option when
yeah.
we have a common reference.
Yeah, that's the common reference, because if we put score, there's no common reference. That makes sense. But then for the third thing that I put there, I was looking at the syntax, right? It just gives you an option for one data frame. So if I combine this, I can combine it with a third, whatever I get from combined, I can put another data frame to combine it to. And I'm sure there
Sorry, but
are, yeah, go ahead.
maybe just repeat what you just did before. Put in that data tree
Data tree, okay,
that you did before.
okay,
Okay,
yeah, go
remove
ahead.
data one. Remove data one.
Uh,
Remove data one completely.
oh, okay, data one, yeah,
Then repeat now using a grid as on.
Repeat what?
They combine where you have on equal to ID. So now use data 2 and data 3 for the combined pd.merge
Yeah,
data
I mean,
2 and data 3, then
yeah,
on equal to grid.
to equal to, oh, grade. Oh, I see what you mean. I see what you mean. Yeah, that should work. Sorry. Oh, because there's a common reference, right?
Yes.
Okay.
Change data 1 to data 2 and then data 2 to data 3.
Yes. 3, to, yeah, because there's a common reference. Yeah, thank you. Let me see, can I go back? I'm not sure I can go back. Okay, let me just go do this. Yeah, that's correct. The only thing I have to look at is to look for a method. There should be a method that can combine 3 or 4 data frames together. Make sense? So, and one of the things I tell people is almost anything you're thinking about, somebody has thought about it and done it. It's not so many things, right, that people have not thought about and done already. Okay, but I hope this was helpful. Again, we have to keep learning little by little. So the next thing is pd.melt. And what does melt do? So look at that, pd.melt. And your method here is you have your pd, again, your pandas.melt. We're taking our combined, and then
Excuse me, sir. We didn't go for the break again. Please, I need
yes.
to use myself. We didn't go for the break.
No, that's fine. Okay, we can go. Let's just go. Let's go for, oh my God,
How
time.
many minutes? 5 or 10?
Let's take 10 minutes. We'll come back 11:05. Thank you. Sorry,
And how
people.
many more minutes?
10 more minutes. Let's take a
Sorry,
10 minutes break.
right here is 3:54, so I think you should be using Nigerian time. I don't know.
Okay. Yeah,
I
that's
think you're
fine. Yeah. So what time
He
would that
said
be for
10
you?
minutes. So just
Yeah, 10
calculate 10
minutes.
minutes in your own zone.
Okay.
Yeah.
Is 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 going to be the next hour, 5 minutes after the next hour. Thank you. See you all in a resume. Yeah, so as we were speaking before, right? How we were able to merge 2 data frames, right? We could merge 2 data frames. Well, what was important is to just have your pd.merge, and then you can merge the 2 data frames. But another thing we can do is essentially, remember, this is what we had to merge 2 data frames from this point to this point. So if I want to merge a 3rd data frame, right, I can essentially, all of this is the combined. Literally, that's what combined is. I can now just say merge plus the combined, which is what I brought from that place. And then I combine another data frame, and then I get this, right? And I get this. So that's essentially what you have here. Or let me see. Let me see if there's, and then another way I can do, but this is a very long way because I can just change this into a variable, right? And variable combined, or else I can still do the same thing. Same thing, I start from here, which is your combined, and then this is the time we combine the second one, and then this is combining the third one, and this is the fourth one. So I can keep expanding it. All I need to do, all I'm just doing is combining two or more 2 data frames. That's essentially what's happening here. Same thing. And then we go to melt, right? What does melt do? Melt is actually very, very important. I used melt a lot in R. R has its own melt.
Excuse me,
Met,
sir.
yeah.
I noticed that in that merge, you kept using just one variable, ID.
Where's the ID? ID. Yeah.
So
Yeah.
we can't use any other. For example, what I mean is, let's say you merge the first set of lists,
Yeah.
so when you now want to do the next merge, let's say
Right.
the DF3, you can't use something else other than ID, or can you?
No, so ID is just one of the references, right? Look at like here,
Yes.
ID.
Yes, I know.
So, for
So I'm
example,
saying
if
after merging the first set with ID, can you maybe for the D3 or D4 use name or age or something or city?
no, so the whole point, which is what I don't know the name of the other colleague that was speaking, right? The important thing is that there needs to be a common reference, right? So if there has to be something that is common to all of them for you to be able to merge them together. Does that make sense?
Because I mean, there's name. Name is common to all of them. Age is common to all of them. City is common to all of them. Everybody has an ID. Everybody has a name. Unlike maybe you're referring to like the uniqueness of the ID. Nobody else can have, two people cannot have the same ID, something like that. So that now restricts it to the ID.
But referring to our data frame has only name and ID. But data frame 2 does not have a name, but an age. So we cannot combine these two with name or an age. But the common one is ID. I suggest this.
Yeah.
No, I'm not sure I understood what the last person
No,
just
okay. So
tried to explain.
look at this data frame, right? This data frame has name.
Yes.
No other data frame has name. Does that make sense?
Oh, I see.
Yeah. So the only common thing, if we had a situation where all of them had name in it, yeah, then we can use name.
Okay, I think
Yeah, makes sense. Yeah. Okay, so the next thing we look at is melt. And let me just go down a little bit. So look at your melt, which is this method, right? This line uses the pd.melt function from pandas to unpivot a data frame called combined, where we're still working with combined that we merge together there. So essentially, you want to change, you're essentially trying to change how data is arranged. That's what melt actually does. Let me just run this because now I have like where are we? Okay. So I think we are working with this data. Where is combined? This is our combined, right? So just give me 1 minute. Let me do something here. Melt. Let me see. No, because I'm not printing, so it's going to take over. Let me just put this here. Okay. So notice what's happening here, right? All I just did was change around the data, around how the data is organized. That's what's happening here, right? And I'm doing it around the ID so that I bring in all the IDs together. That's what melt does. But let me just try to run, see if it can make sense from here. So the line uses the pd.melt function from pandas to unpivot a data frame called combined, right? This is supposed to be in. So PD transforms a wide format data frame, right, to a long format one by keeping some columns fixed, called the identifier variables or ID variables, turning the remaining columns into two columns, one for variable names and the other for values. So instead of having this, just think of it like your horizontal, the way, because some data, right, is better managed. Like if you want to work with some data, you want to make them horizontal and long. If you have it vertical and spread out, right, it's hard to analyze. So Melt helps you change it to a vertical data. right? But then there needs to be some kind of common reference again, which is what you have here, and you're doing it around the ID. So everything will just come down here. Let me see. Let me see. Just give me 1 minute. Let me try something here. Oh no. So that's not what I'm looking for. Is it combined or combined D? Okay, that's not what I'm looking for. So the explanation of the parameters combined, right, which is our original data frame, and then ID, the variable name, tells pandas to keep the ID column as it is. Don't melt this particular column. All other columns will be unpivoted into 2 new columns. So essentially, we're using ID as a reference. Every other thing, if we had a third column, let me go look for grade. Okay, so let me try to add one additional column. Just give me a minute. Let me just put an additional column here so that you can see what I'm trying to say. I don't know, what can we call this column now? I hope I'm not making any mistake here. I don't want this to throw up an error. Let's see. I don't know what to call this.
I don't think you can have score twice.
Sorry? No, yeah. Yeah, I saw
You
that.
haven't scored twice.
Yeah, I saw that. I'm
Yeah,
trying to change it to something else.
Okay.
But I'm trying to make sure I'm not making it. And look at that, I've got one mistake here. Oops, no.
Remark.
You said what?
Remark.
Oh, should I use remark here?
Can use remark.
Okay.
of course.
I don't even know what remark is, but okay. But it can be anything. Let's use something here. I don't know what this, something that will make sense, right? But let's just use, okay. Oh, I see what you mean by remark. So what do we use here?
Remark, sorry, sir, remark, what he meant is remark, probably write, fail, or pass. So it will be in strings.
You mean here?
Yes,
Yes.
So let
the third
so let
column want to ask, want
no
to
so
add
so let's use
remark.
something like here will be a remark, right? Is that what you all mean?
Yes, the key will be remark, the value will be fail or pass, depending on
Pass
the
of
score.
yes.
That's
Yes.
what he's trying to say, right?
Yes.
Okay.
So no, so let me just do this so that to avoid any kind of confusion, right? So let's say 70. And if you observe any mistake, please just let me know, because I'm just trying to illustrate. Sorry? So okay, see this, right? So we have this ID, this is their score, new score, grade, new score, whatever. We just have something like that going on, right? If I decide to, let me just go back to here. So look at our current combined, right? If I decide to melt it, all it's just doing is changing around, turning all of this like to a vertical. Just 1
Okay,
minute.
like transposition.
You say what? Yeah, you see what it does? It just transposes it, kind of transposes it. This is what has happened. You noticed it now? Does it make sense?
Yes, very well, sir. Very well.
Yeah, yeah. But everything is referenced around the ID. So this is the explanation and all of that. So there are a couple of other things here, but I will let you, because this is just a additional example for you to just play around with how to load data, how to handle missing figures, some of which we've done already, how to filter figures, where, for example, if I have a data frame, right, and I put a colon and I put age, right, all I'm doing is I'm trying to get all of this age. That's what I have here. And I say greater than 30. So I'm trying to have it get me all of the ages that are greater than 30. If I filter that, right, notice the only thing that is greater than 30 is 35, right? And that's why we have 35 here. So if I change it to less than, for example, right, it's going to change and give me what's going on. Why is there an error? That doesn't make sense. Age. No, it's supposed to give me key error. Somebody look at this. Tell me what's wrong here. Well, let me run this. So it's not supposed to give me an. Oh, it's giving this one too. Is okay. Maybe because I haven't run this. Let me go run it first. Sorry. Okay, yeah. Now it should work. Okay, now if I want all of the people that are below 30, it will give me all of them that are below 30. If I say it's below or equal to 30, it will give me everything including 30. So that's how you do filtering. And again, the important thing is to have the name of the data frame, and then in parentheses, the column that you're targeting. But then again, you can go through all of these, how to group and aggregate data, renaming data, all of that information is here, and then this is a real example, right, where you are actually pulling data from Titanic, but you're using Seaborn, and then you can run all of that data, you do your head, this is some of the missing values and how you handle it, the feature engineering, data aggregation, and all of that. But what I want to do is, and I'm going to let me show you something. So I think that's what we have for today. And then we're going to go do a little of GitHub. I'm going to have yeah, Christian, just go ahead and ask your question.
Okay, so thank you so much.
Yes, sir.
I think it's a little clearer now.
Okay.
The methods that are involved in data cleaning. But there's one area that is giving me problem.
Okay.
Before we went for break, we had the none and we had NAN.
Yeah.
So what's the difference between none and NA? If a data point is none and the data point is NAN, what's the difference in how the system handles it?
So NAN actually means that there is nothing there. You know what I mean, right? So if you try to remove NAN would not be removed, so but I will in a separate set of examples, right? You would actually see what NAN does. All right, I will just give me a minute. I'm gonna have to stop this particular class and then we will continue.